Climate change isn't just a distant threat, it's an unfolding reality shaped by complex scientific processes and undeniable evidence. But what's really happening, and why? To understand the science behind climate change, we need to delve into the forces driving our planet's warming and their far-reaching consequences. The greenhouse effect, nature's thermostat. At the heart of climate change lies the greenhouse effect, a natural process that makes Earth habitable. The sun emits energy, which reaches the Earth in the form of light. Some of this energy is absorbed by the planet's surface, warming it, while the rest is reflected back towards space as infrared radiation. Here's where greenhouse gases come in. These gases, like carbon dioxide, CO2, methane, CH4, and water vapor, trap some of this outgoing heat in the atmosphere, preventing it from escaping into space. This trapped heat keeps the planet warm enough to support life. But human activities have supercharged this process. Burning fossil fuels, deforestation, and industrial activities have dramatically increased the concentration of greenhouse gases in the atmosphere. CO2 levels, for instance, are now higher than at any point in at least 800,000 years. This enhanced greenhouse effect traps more heat, causing global temperatures to rise. Evidence of a warming planet. The evidence of climate change is everywhere. Global temperatures have already risen by about 2.2 degrees since the late 19th century, and the last decade was the warmest in recorded history. But temperature is only part of the story. Melting ice and rising seas. Polar ice caps and glaciers are melting at alarming rates. The Arctic is losing about 13% of its ice per decade, and the melting of land ice contributes to rising sea levels. Since 1880, global sea levels have risen by about 8 inches, and the rate is accelerating. Extreme weather. A warming climate fuels more intense and frequent extreme weather events. Heat waves are hotter and longer, hurricanes are stronger, and rainfall patterns are shifting, leading to floods in some areas and droughts in others. Ocean warming and acidification. The oceans absorb over 90% of the excess heat trapped by greenhouse gases, causing marine ecosystems to suffer. Warmer waters disrupt weather patterns and marine life, while increased CO2 levels make oceans more acidic, threatening coral reefs and shell-forming organisms. Why human activity is the driving force. Natural factors like volcanic eruptions and solar cycles have influenced Earth's climate in the past. However, the current changes are occurring at an unprecedented pace and align directly with human activity. Fossil fuel combustion releases billions of tons of CO2 annually. Deforestation eliminates trees that would otherwise absorb CO2, while industrial agriculture releases methane, a greenhouse gas far more potent than CO2 in the short term. Scientists use climate models to distinguish natural climate variability from human influence. These models consistently show that the rapid warming observed today cannot be explained without accounting for human-caused emissions. Feedback loops, worsening the crisis. Climate change is not a linear process. It's amplified by feedback loops. For example, melting ice. Ice reflects sunlight, helping to cool the planet. As ice melts, darker surfaces like ocean water absorb more heat, accelerating warming and further melting. Thawing permafrost. As permafrost thaws, it releases methane and CO2, amplifying the greenhouse effect. Dying forests. Forests act as carbon sinks, absorbing CO2. Warming temperatures and deforestation has reduced this capacity, releasing stored carbon into the atmosphere. What's at stake? If global temperatures rise beyond 1.5 degrees Celsius to 2 degrees, the consequences will become increasingly severe. Ecosystem collapse. Many species will face extinction as they struggle to adapt to rapid changes. Food and water scarcity. Changing weather patterns threaten agriculture, while melting glaciers imperil water supplies for millions. Human health. Rising temperatures exacerbate heat-related illnesses and expand the range of vector-borne diseases like malaria. Displacement and conflict. Rising seas and extreme weather could force millions to migrate, potentially sparking resource conflicts. Can we turn the tide? The science is clear. To mitigate climate change, we must drastically reduce greenhouse gas emissions. This involves transitioning to renewable energy sources like solar, wind, and hydro, protecting and restoring forests to act as carbon sinks, investing in energy efficiency and sustainable infrastructure, developing carbon capture technologies to remove CO2 from the atmosphere. The challenge is monumental, but so is the opportunity. Addressing climate change not only averts disaster, but also creates a more sustainable and equitable future. Thank you so much for watching our video. Make sure to subscribe to our channel and press the bell icon to get all the latest updates every day. We will meet you in the next video.